So hello guys, welcome back to my YouTube channel. I am Nandini and I scored 632 out of 720 in NEET 2024 examination, and due to the scam and all I couldn't get a government MBBS seat, so I'm preparing for NEET 2025. So if you are new to this channel and you are watching my video for the first time, I would like you to also revisit other videos of my channel also, and you'll get to learn a lot from it, I can assure you that. And if you find this channel helpful, then do subscribe to it, and also like, share my videos. That really motivates me because it take a lot of effort to make the solutions for the answers for you all people. First I have to solve them on my own, and then I try to figure out shortcut methods for you people, so that you need not hustle to search for the answers, because I myself as a NEET aspirant know that how much worth the solutions keep for us, because it's really very hectic task to find the solutions from ourselves, so we tend to neglect the questions and move forward without learning them. But that is not the case with my channel. Here you will get the solution for all the questions of Allen Achiever test series, and it will be of great help to you. So without wasting any further time, let's get into the video. And if you find this helpful, then do please like, share and subscribe. It really matters to me a lot. So let's get into the video. So the first two part for this video are there on my channel, so you can visit that and see the solutions up till question number 35. Here I'll be discussing from question number 36. Okay, I also have my Allen answer solution answer key. So with that I'll be explaining you all the answers to the questions. I'll try to keep it as brief as possible, but at the same time it will be as detailed, so that you need not get confused with the answers. So the first question is like two identical balls having like charges of players at certain distance. You'll read the question by yourself only. Okay, so here what happened is that first of all the force is k q1 q2 upon r square. Okay, k q1 q2 upon r square, and then what it is saying is that f dash becomes k q1 q2 upon 2 whole square, because when we bring two charged spheres in contact, then the resultant charge on each sphere becomes q1 q2 upon 2. So we will put here q1 q2 upon 2 whole square, which is the charge on each sphere, divided by, because the distance is halved, so r upon 2 whole square, and this whole is equal to 4.5 times the previous force. So when you equate this, then you will get q1 upon q2 as 2. Okay, so first question done. Now second question is that three equal point charges are placed at ABC, and if theta is equals to 45, then the net force on B. Okay, so here again you'll see net force on B is asked. So this will these two will repel each other, because on B also plus q charge is placed, so plus q will repel each other, plus q will repel each other. So f and f, the resultant becomes root 2 times of f, and f itself is k q1 q2 upon r square, so q square upon r square, and r is how much? This is r, so this is root 2r, so this root 2r whole square becomes 2r square, kq square upon 2r square, and net force is equals to f root 2, so root 2 times of this kq square upon 2r square. So this root 2 gets cancelled with root 2, so kq square upon root 2r square. So that is the answer to the second question. I hope it's visible. Now the third one. Okay, so the third one is that 8 point charges having magnitude q are fixed at the vertices of a cube. Okay, electric flux through square surface ABCD. So through the square surface ABCD, electric flux is being asked. So the charges touching the corners ABCD will have zero flux. So the remaining 4 charges ABCD kept at EFGH will constitute the electric flux, and that will be equal to Q upon 6 epsilon naught. You can see for the solution here also that for the surface ABCD or EFGH, ABCD or EFGH, phi due to the charge touching the surface is always 0. Now flux per corner charge not touching the surface, which means that these 4 is equals to 1 by 3 q upon 8 epsilon naught, and due to 4 corner charge not touching the surface, it will be 4 into this this value of q upon 24 epsilon naught, which will be q upon 6 epsilon naught, okay, and not q upon 24 epsilon naught. This statement is wrong. Now this statement that electric flux through cube is q upon epsilon naught, so that is correct, q inclusive upon epsilon naught. And electric flux through the square of EFGH, again EFGH is being asked, so the flux due to these 4 will be 0, but these 4 will constitute the flux, and that will be equal to q upon 6 epsilon naught. This is correct, this is correct, so answer goes as second option. Okay, moving further to the next question. Okay, find the potential difference between the point E and F in the joint figure. Assume E and F are the midpoint of AB and DC. AB and DC. Okay, these are the midpoints. So this becomes 3, and this though is 4. Okay, so this is also 3. This is 4. So which means this is equals to 5. Now I'll show you the solution here. See, we have to calculate potential difference between the point E and F, which means VE minus VF we need to calculate. Okay. So VE will be, what will VE will be? So we know that KQ upon R is the potential due to a point charge. So for this, that it will be K small q upon 3. Okay, for this it will be KQ upon 3. That will become 2 KQ upon 3. Okay, and for these two, what it will be? So this is 3, this is 4, then this becomes 5. So this will be KQ upon 2 into 5 whole multiplied by 2. Right? So this becomes KQ upon 5. So here we see that VE is equals to K common, 2KQ by 3, 2Q by 3 plus Q by 5. Okay. And what about F? So similarly for F also you will calculate. VF will be like for these two, it will be KQ upon 2 divided by R is 3 multiplied to 2. So this again becomes KQ by 3. So you can say KQ by 3. And for these two charges, it will be KQ by 5 times 2. So this will be 2 KQ by 5. Okay. So I hope it's visible. So when you will take the difference, then it will come out to be 2 KQ upon 15. And if you put the value, then you will get 1.2 to the power 9 Q volt. Okay. So I hope that it's clear to you all. Question number 39. Moving to question number 40. Okay, you will read the question on your own. So I'll tell you the solution. So we know that W is equals to Q delta V. Okay, and it's moved from infinity to a point which is at a distance of 2 centimeters from the surface of the sphere, which means from the center it will be 4, because the diameter is 4, which means the radius is 2, and from the surface the distance is 2, so the whole distance becomes 4 centimeter, right? And the work done is equals to Q delta V, and delta V is like V minus of V infinity, and V at infinity is taken as 0. So it will be Q into potential, and potential due to a sphere is KQ upon R, and R will be from the center, which is the 4 centimeter, and Q also is given. Basically Q is not given. Q per unit area is the density which is given. So Q will be area into density. Okay, and if you see the solution over here, then see here, work done is equals to Q into delta V. So Q is given, and delta V will be infinity, so will become 0, and V is equals to KQ upon R, KQ upon R, and Q upon area is equals to sigma, which is given. So Q is equals to A times sigma, so K sigma A upon R. Okay, and A will be 4 pi R square, sigma will be sigma, K will be K, and Rx will be 4 centimeter, which will be converted into meter. So accordingly you will get the answer. Okay, that is equals to 14.4 pi joule. Okay, I hope it's clear. Moving forward to the next question. A large hollow metal, okay, is also potential of the final potential of A. Okay, final potential of A is being asked. So initially we have such a such a situation is given to us that a large hollow sphere A of radius capital R is positively charged to a potential of 100 volt. So let's suppose that this is the A sphere and this is the B sphere and this capital R. Okay, charged to 100 volt. Okay, and a small sphere B of radius R by 5. So this is R by 5. I hope it's visible. R by 5 is the small sphere, also positively charged to a potential difference of 100 volt. Okay, 100 volt it is charged. 2. I hope that the video quality is okay and fine, and if any problem then do let me know in the comments, and please share the video if you like it. Okay, so I really have to hit 100 subscribers as soon as possible. That is my first target, so if you could all help me, then it will be a great, you know, great gesture from your side. Okay, so yeah. The second sphere B is having a radius of r by 5 and it is charged to 100 volts. Now initially for K, the potential is KQ1 upon R, which is equal to 100. So Q1 value comes out to be this much. For B, the potential is KQ2 by R by 5 and the potential is 100 again. So Q2 value becomes this one. When whole charge transfer to the outer sphere A, because what is happening is that B is placed inside A and they are connected by a wire, which means that both of them are conducting spheres, so the whole charge will be transferred to A. Okay, finally when the whole charge will transfer to the outer sphere A, Q total becomes Q1 plus Q2, and Q1 plus Q2 is 600 R by 5K. Okay, now the potential of A is again KQ upon R, but here the Q is Q total. And Q total is this much and K upon R remains the same and Q total is put, then you will get 120 volt as the final potential of A. Okay, so I hope it's visible. So it's done. Now 42nd number. In a certain region, the electric field exists along the x-axis, which is uniform, given AB. Okay, AB is 2√3. BC is 4 meter. Point A, B, C are in the XY plane. Find the potential difference VM minus VM between point A and B. Okay, point A and B. Okay, this is 2√3 meters. So this distance will be 2√3 cos 30. 2√3 cos 30, which is √3 upon 2. So this will become 3. Okay, and we know that E is equals to minus dV upon dr. So dV we need to calculate. So E dot dr will be dV. So electric field is given as how much? E is E only, and distance between them are 3. Is 3, so it becomes 3. Okay, and so delta V, as we know, is equals to integral E dot dr vector. Okay, and A to B we need to integrate, so it will be E into 2√3 cos 30 degrees. So it will come as 3E. Okay, so I hope it's clear. Moving forward to the next question, 43rd number. I hope it's visible. Okay. 43rd number. Here it is asking the change in the momentum and the change in the kinetic energy between 1 to 3 seconds are respectively. So first we will calculate the acceleration, which is change in velocity upon time, which is given as here you can see 6 upon 1. So the acceleration comes out to be 6. Okay, and change in momentum is the delta P, which is equals to m into V final minus V initial. Okay, and that comes out to be minus 12 kg meter per second. And change in kinetic energy is equals to 0. So only one option resonates here. So that is the answer. Now moving forward to the next question, 44. So we know that R is equals to R naught 1 plus alpha delta T. Okay, so R here is like V is equals to IR. So R is equals to V upon I. So V is 200 upon I is 10 ampere is equals to R naught 1 plus alpha. Delta T is how much? 15 minus 0. Okay. Now what's saying that current fallen to 5 ampere. Okay, so the voltage remains the same. So 200 upon 5, which is 40, is equals to R naught 1 plus alpha delta T, and delta T is being asked, I think. Okay, so T minus 0 is being asked. So accordingly, if you will calculate, then there are two variable R naught and T, and even if you divide it, then R naught gets cancelled. For 40 and 20 gets cancelled. So 1 by 2. 1 by 2 is equals to 1 plus 15 times of alpha divided by 1 plus alpha T. So from here T comes out to be how much? 264 degrees Celsius. So I hope that this is clear to you. Okay, once you solve it, you will get the answer. Moving forward to the next question, 45. Okay, so here it is saying that the same mass of copper is drawn into two wire connected in series, and current is passed through them. The ratio of heat produced, the H is equals to I square RT. I square RT, you know that, and because the current is passed through them and they are connected in series, so current remains constant, which means heat is directly proportional to the resistance. Okay, heat is directly proportional to the resistance, and we know that here the same mass is being said. So density is equals to mass upon volume, and mass is same. Okay, so here same to 2 wire, these and these meter thick, so volume remains the same. Volume is the same, so volume is area times length, which is constant, okay, and so length is inversely proportional to area, which means that it is inversely proportional to radius square, because area of wire will be pi r square, so inversely proportional to radius square. We now know कि heat is directly proportional to resistance, and resistance is equals to rho L upon A. Again rho is constant, so L is directly proportional, I mean inversely proportional to r square, so we'll write 1 by r square, and area ka r square, so it will be 1 upon r to the power 4. So once you'll calculate it, heat is directly proportional to 1 upon r power 4, which means h1 upon h2 is equals to r1 power 4 and r2 power 4. So it will be 81 upon 16. Okay, so I hope that it is clear to you all. Moving forward to the next question. KVL equation, you need to write it. Okay, so KVL equation you need to write. Why do I feel that the camera quality is not up to the mark? I think I'll cover next questions, a further question in the next video. I'll show it now only, and I think that there is some issue with the camera quality, so I'll just recheck it once, and further solution you'll get in the next video, and I'll pin the video link in the comment. And if you find this helpful, then please do like, share and subscribe, and meet you in the next video.